the information from the sender to the receiver, at that time symmetric type of activity is taking place, because we are interested in increasing the security, but at the same time required for sending and receiving has to reduce. So at the session level, the system is working as if it is the symmetric encryption, but at the system level, it is a private and the public key combination of public key encryption. So several different approaches are possible involving the private key of one or both parties. How can you ensure such the transaction? Different. determine Euler's function phi n directly without first determining value of P and value of Q. Again, this enables determination of decryption key D, which is once again inverse of encryption key mod of the Euler's phi function. Third one is determining D directly without first determining Euler's phi function. So brute force method or some guess work he may try to do here to do it. Three types of possible attacks to the attacker. Till this particular date, no breakthroughs have been reported. So means modulus factorization, which is involving primary keys and the Euler's phi function and inverse operation to come out with decryption, is very complicated, and it is not providing any support to the attacker. By like this, it is providing more safer exchange of the information. Second type of attacks may be using the small exponent attack. Small exponent attack involves attack on the way the RSA algorithm is working, how it is being used. It tries to exploit the idiosyncrasies in the way RSA is used. Means, if one company is using RSA algorithm and sending it, another company is using RSA algorithm which is of different type of algorithm, like that when they are trying to do it, then what are the most famous techniques being used? Studying them and trying to exploit to carry out the exponents. By looking at this example, we can get some meaning out of it. Now suppose an attacker eavesdrops upon the ciphertext. What do you mean by eavesdrops? Eavesdrops in the sense whenever I am interested in sending any message, or whenever I am using my internet banking application on mobile to carry out any activity, what keys and other things I enter on the system is always encrypted. The attacker cannot make a sense of it. But he will be listening the sound of the key, tuck, 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 like that. Based on the gap between the two keys, or based on the speed of our typing, he will be guessing it, what we have typed it. Based on that, he is trying to build the SID. So upon the ciphertext C1, C2 and C3. So these are related to the message M. Now, the ciphertext is the overall activity of the message M and mod N1 function. Second, has been obtained by carrying out mod N2. Then the third ciphertext is mod N, the message M3. Since the prime factors N1, N2, N3 will almost certainly be distinct, it follows that N1, N2 and N3 are pairwise relatively prime numbers. So this key plays very important role. They are pairwise relatively prime. Hence, knowing the residues M3 mod N1, M3 mod N2 and M3 mod N3, we can use Chinese remainder theorem to reconstruct M3 mod capital N. Since M is smaller than N1, M is smaller than N2 and M is smaller than N3, M3 will be smaller than N. Hence, M3 mod N equal to M3, and so M equal to M raised to 3 mod N raised to 1 divided by 3. A more obvious attack with an encryption key E equal to 3. It occurs if an attacker knows or guesses that the message M is less than N raised to 1 by 3. In this case, the operation cube root modulo N on the ciphertext reduces to the regular algebraic cube root of an integer. Thus, calculation becomes simpler, and we are going to get the encryption key, and based on encryption key, we can arrive at the inverse of that, which is decryption, and get the original message. This is called small exponent attack. Chinese remainder theorem plays very important role here. Next one is side channel attacks. Paul Kocher demonstrated that a snooper can determine a private key by keeping track of how long a computer takes to decipher the message. So when message is being sent, which will be in the digital form, from left to right, we go on checking it up. And when the message is in the digital form, when it is having 1, some calculation takes place there. Because of that, it takes some time. If there is a 0 value in the message, then at that time, no calculations are being carried out. So, like that, when more time is being spent on the message on a particular digit, the attacker assumes that there is some value there. Then after that, there is less. After that, more value, more time. After that, less time. After that, less time. Then he understands that the value, possible values may be 1, 0, 1, 1, 0. Because 1 has taken more time, then 0, no time, then 1 is taking the more time, then more time, then less time. So he assumes that the person may be working on 1, 0, 1, 1, 0. Like that, in the side channel attacks, based on the pattern of the time being spent, we try to rebuild. If the observed time to execute decryption algorithm is always slow, when in a particular iteration of a decryption on a particular bit, which is assuming 1, then there will be slow process taking place. And if it is 0 is there, then processing will be fast. These observations are being done. So these are the different type of things. These are the aspects we wanted to discuss today. With this, and what are the typical applications of public key cryptography, and what are the different types of issues in the public key cryptography, are the points that we discussed today. In summary, by making use of a session key, which is a random number, we can overcome the limitation of public key cryptography. Most of the time, complaint on it is slow like that. But by using the secret key at the session level, we can speed it up. And also, because of the use of primer numbers and other things, it is having the higher level of security. So with this, we come to the end of this particular session. Thank you.